continuing with learning about trigonometric identities. Okay, we're going to return to sum and difference identities because I want to compute sine of 2a. Okay, what if I want to be able to double an angle? Well, I can think of this as sine of a plus a. Using the sum and difference identities, this is sine of a cosine of a plus cosine of a sine a. Notice that these two things are the same because it doesn't matter what order we multiply in. So this is twice sine a cosine a. Okay. Now, we do the same thing with cosine. And I end up with cosine squared a minus sine squared a. Now this one we can actually do something a little bit more with. Because if you remember, sine squared a plus cosine squared a equals 1. This means that if I solve it for sine squared, I get 1 minus cosine squared. Or I could have also solved it for cosine squared and get 1 minus sine squared. Now, these two substitutions are going to be used a lot. So, if we substitute out the cosine squared, I get 1 minus sine squared for the cosine squared, and then minus the sine squared that was already there, or 1 minus 2 sine squared a. Going back to here, if you substitute out the sine squared instead, you get 2 cosine squared minus 1. So this gives us a class of identities called the double angle identities. We have that the sine of 2a is 2 sine a cosine a, and that the cosine of 2a is cosine squared a minus sine squared a, or 1 minus 2 sine squared a, or 2 cosine squared a minus 1. So we have 3 double angle identities for cosine, and all of them will be useful. Okay. Now, if we take just these last two and solve them for the sine squared or the cosine squared, we end up with what are called the power reducing identities. Okay. So, if I take cosine 2a equals 1 minus 2 sine squared a, and solve for the sine squared, I get the power reducing identity for sine. And if I take cosine 2a equals 2 cosine squared minus 1, and solve for the cosine squared, I am going to get the power reducing identity for cosine. And notice that they're identical except for the plus or minus in front of the cosine 2a. Okay. Now, the other thing I can get from the double angle identities is another class of identities. Only these identities you have to be very, very careful about. So they actually come with warning number 30. And the warning is, don't use them unless you have to. You'll see why when we get to them. And I'll also, when we get to those problems, show you the only type of problems that I will voluntarily use a half angle identity for. So, I'm going to take these same two versions that I did for power reducing. So starting here, okay, I'm going to take a square root of both sides and do a little substitution. I'm going to let u equal a divided by 2. No. Mess that up just a little bit, sorry. Let u equal 2a, which means that a will be u divided by 2. Okay. If I plug those into here and then take a square root, I get the half angle identities, which are that sine of u over 2 is plus or minus the square root of 1 minus cosine u all divided by 2. And cosine u over 2 is plus or minus the square root of 1 plus cosine u all over 2. And here you should see why we don't want to use these. First of all, we don't like square roots. But even worse, we have plus or minuses. Now, in actual fact, for a given u, only one of the plus or minus is actually true. The problem comes in that these identities don't tell you which one will be true for any given situation. So we will only use the half angle identities when we are totally able to determine if it will be plus or minus.